The subject guide has been designed to meet research needs of university students, aiming at developing metabolizable energy feed intake prediction models for crazy merino sheep, and have been integrated in decision support tools developed by the CSIRO in Canberra. So far, there has been very little experimental evidence to indicate how different crazy management systems can alter pasture components to accomplish the best match of nutrient requirements of the grazing animals with the ability of the pasture to supply the required nutrient, especially in grazing regions with variable climatic conditions. In an attempt to assess the whole farm sustainability and profitability across the soil, water, plant, animal economic continuum, the Cicerone project was established. That was a producer-led organization. It was established in the Northern Tablelands of New South Wales in 1999, and it attempted to use the metabolizable energy to measure the match between pasture supply and animal nutrient requirements. Metabolizable energy is a decision tool assisting livestock producers to match energy requirements of livestock with the energy concentration that can be supplied by the pasture. This can assist the livestock producers in developing guidelines and rules for their grazing enterprises to enhance the desirable component of their temperate perennial pastures, the one that we say they are deep-rooted, fertilizer responsive, plus persistent legumes. As we can see on the flow chart here, we have the pasture supply and animal demand. On the pasture supply side, the first component that we talk about is herbage pasture growth rate in kilograms dry matter per hectare per day. And on the pasture, when you put your animals on the paddock, they will have the herbage mass. You are giving them the feed on offer. That feed on offer, whether it's green herbage or dead herbage mass, it has been promoted by pasture growth rate, which grows daily. And that pasture growth rate leads to green herbage in kilograms dry matter per hectare. And if the animals are not utilizing the green herbage, then it turns into dead herbage mass. And if the dead herbage mass still not being utilized by the animals, then it turns into decomposed biota back into dry matter in the soil. Both the green herbage mass and dead herbage mass, they have their digestibility percentage. We call it quality of the pasture or nutritive value. And because when you have your animals on the paddock, you don't want the pasture to be wasted. If the animals are not grazing it, it loses the quality. But if animals are utilizing it, it promotes regrowth and then it gives higher quality. Same time, you don't want the pasture to be overutilized because it inhibits the regrowth of the pasture. So both green herbage and dead herbage mass, they have digestibility content that is being measured to determine how much nutritive value the animals are getting out of the pasture. Once the pasture has been consumed by the animals, then we have metabolizable energy, what we are interested in to predict the daily intake of these grazing animals. It can be either for the fleece, if you are keeping sheep, merino sheep in this case of the subject guide, keeping merino sheep, and also for the live weight of the animal, because we know that we keep merino sheep for both harvesting wool and also for the meat. The ultimate product there is the daily intake that we are going to calculate. I will move on the, just move this flow chart and go into the equation. On the equation here, we see the first equation there, the digestible dry matter. And this digestible dry matter is being calculated based on the dry matter digestibility percentage the one that I was saying, that is the quality of the pasture, by the green herbage mass in kilograms dry matter. And then the second equation we see is DSC per hectare, which is the dry sheep equivalent per hectare, calculated based on the number of animals that you put on the paddock by the DSC rate divided by the paddock size, how big the paddock is. The third equation is ME demand, what the animals are requiring, the nutrients that the animals require from the pasture, by megajoules ME per day, calculated based on the average live weight of the livestock, multiplied by standard ME demand of the weather, times the DSC rate for that animals. In this case, because you are going to use a pregnant ewes, and then we see how much the DSC rate for that pregnant ewes, and divided by the average standard weight of the weather live weight. The fourth equation there is MD, which is the concentration of the pasture, or the density in megajoules ME per kilograms dry matter, and is calculated based on this equation 0.17, dry matter digestibility percentage minus 2. The fifth equation is the intake kilograms dry matter per head per day, calculated based on the ME demand of the animal, what the animal nutrient requirements are, divided by the MD, the pasture concentration, by megajoules ME per kilograms dry matter. Let's scroll down and see this exercise that I have done here. We are assuming that we have 125 pregnant ewes with an average live weight of 45, and given the dry sheep equivalent rate of 1.3 because they are pregnant and some of them are carrying twins, and they're grazing on a pasture of 10 hectares, that's the size of the paddock, with average green herbage mass of 1125 kilograms dry matter per hectare. That's the feed on offer, which has the dry matter digestibility content of 80%, and this pasture is highly digestible. That means it has more content of green. And note here that standard weight that we are using for the weather, 50 kilograms of the live weight of weather, with the DSC rate for the weather 1.0, and the ME demand for the weather 9.0 megajoules ME per day. And we have that equation there. So let's do this equation and see what kind of the intake ultimately we are going to get. That digestible dry matter, the DDM, as I said, when you put the animals on the paddock, giving them the feed on offer, which is 1125 kilograms dry matter per hectare, not all of that pasture is digestible. So we need to calculate how much is the DDM of that pasture based on the dry matter digestibility percentage. In this case, it is 80%. And that gives us the figure of 900 kilograms dry matter per hectare. That 900 kilograms dry matter per hectare of the green herbage, we call it DDM, is digestible to the animal. The second equation there, the dry sheep equivalent per hectare, we have 125 pregnant ewes, and their DSC rate, because they are pregnant, is higher than that one of weather, is 1.3, and you divide by the size of the hectare of the paddock, which is 10 hectares, and it gives us 625. The third one is the metabolizable energy requirements or demand of this animal, the pregnant ewes. Their average live weight, which is 45 kilograms, multiplied by the standard ME demand of the weather 9.0, times by their DSC rate of 1.3, divided by the average live weight of the weather, and gives us a figure of 10.53 megajoules ME per day. The fourth equation there is the concentration and density of the pasta. That gives us that figure of 11.6 megajoules Me per kilograms dry matter. Now the intake value for these animals, when we divide that Me demand of 10.53 demand by this pregnant ewes by the MD of the pasta 11.6, it gives us the intake of 0.91 kilograms dry matter per head per day. I'll just scroll down and show you. If we decide to calculate the intake for this animal based on their live weight, what normally most people will do, we say we use 3% of their live weight. In this case, their average live weight 45. That gives us their daily intake of 1.3 kilograms dry matter per head per day. You may wonder why now when you calculate based on the average live weight, the intake is higher, but based on the age of the pasta, the intake is lower. I'll explain that. The reason why when you calculate by the age of the pasta, because this pasta has got a 80% dry matter digestibility percentage, which is highly digestible. That reduces the intake of the animal. Why? Because it's highly nutritive. So the animals will consume less quantity of this pasta, and then to meet their nutrient requirement at low intake, they get satisfied, being absorbed because it's highly digestible, high quality, and then it can be absorbed to produce more fleece of higher quality and also for the meat. But if you calculate based on their percent live weight, sometimes you put those animals there, the digestibility content is low. That means the intake might be high, not necessarily that they're getting more satisfied. That means that they're consuming more of the quantity of the pasta, more herbage mass, probably not highly digestible. So they consume more to fill up their rumen, but not being absorbed to produce more of the fleece and of the live weight. And that's the end of this equation that I want to demonstrate. Later on in another video, I'm going to show the spreadsheet developed by the Sheep Explorer spreadsheet calculator that has been developed by the CSIRO.